Welcome friends. Let us continue our discussion over the 8 previous year question solutions. So as we have already started with the subject electromagnetics. So this is the question displayed on your screen belongs to electromagnetics and specifically the topics of waveguide. This question appeared in the GATE exam in the year 2019 for 2 marks. So now let us read the question carefully first before solving. So the dispersion equation of waveguide which relates the wave number k to the frequency omega is k of omega is equals to 1 over c square root of omega square minus omega naught square, where the speed of light c is equals to 3 into 10 power 8 meters per second, which is a universal constant, and omega naught is a constant. If the group velocity is 2 into 10 power 8 meters per second, then the phase velocity is. So after reading the question, we can say that we have, or the examiner has given us a group velocity, velocity of light, which is a universal constant, and the last thing as the expression for your wave number, and he wants us to find out the phase velocity. So now let us first think what are exactly the concepts behind this question. So here, if while reading the question, you might get a question that what is group velocity, what is phase velocity, what is the wave number. So now let us discuss these things one by one. So let us start with your group velocity. So the group velocity is denoted by Vg. It is the superposition of waves of varying frequency can result in a group of waves, or we call it as envelope of waves. When this envelope of wave travels, it will travel with some velocity. So that velocity is called as group velocity, which is given by mathematically d omega over dk. So we can say rate of change of angular frequency to rate of change of wave number. So here, as you all know, omega is your angular frequency and k is your wave number. So now we don't have the value of d omega by dk right here, but as we can see in the question, here the examiner has already given us the value of wave number. So let us first take down this value of wave expression for wave number, which is equals to 1 over c square root of omega square minus omega naught square. Okay, so now as we don't have the value of d omega by dk, so let us take a derivative of this expression of wave number, expression of k, with respect to the angular frequency omega, and then we will try to take an inversion of the expression to get the value of d omega by dk. So now let's see dk, derivative of k with respect to omega will reduce to 1 over c derivative of, let us say, of the format of root x. So we will get 1 over square root of omega square minus omega naught square, and the derivative of x, that is 2 omega. So now by solving this equation, simplifying this equation as well as putting it here, taking inversion and putting it to the value of Vg, we can get here, putting this value here, we can get c into square root of 1 minus omega naught over omega square. We are just solving this 2 to get cancelled. We will take omega as common, and then omega gets cancelled. So we will now we have the value of group velocity. Now the next question arises in your mind is, what is your phase velocity? Basically, first let us go to the next slide. Phase velocity is denoted by Vp, and by definition the velocity with which a specific component of waves travels in the space is called as phase velocity, which is mathematically given as omega over K. Again, omega is your angular frequency and K is your, as you will know, K is your wave number. Now let us put this equation of K of omega in this K here. By solving it, finally we will get C over square root of 1 minus omega naught over omega square. So now let us observe. I will just again write down the equation which we will obtain from for group velocity here for your easiness comfort. C square root of 1 minus in bracket omega naught over omega whole square. So now let us multiply Vp with Vg, which is equals to, while multiplication, this square root term will get cancelled and we will get it as C square. Now we can understand here, we know the value of group velocity. C is a velocity of light, that is universal constant. We know the value. So now we can find out the value of Vp from here. So the equation can be modified to Vp is equals to C square over Vg. So I will just put the numbers here. Vp is equals to 3 into 10 power 8. That is your velocity of light over the velocity of the group velocity value is given here as 2 into 10 power 8 meters per second. So I will just write down 2 into 10 power 8 meters per second. So one thing you just take care in these kind of questions, the units should be consistent while putting the values in the final for final calculations. So right now here the velocity of light is given in meter per second and the group velocity is given in meter per second. So unit is consistent. So there is no need of changing anything. But if the unit is not consistent, please keeping these things in your mind and change the unit, make all the units consistent and then put the values. So after solving this, you will get the answer as 4.5 into 10 power 8 meters per second. This is your answer. Let us check the options and D is your correct option. Okay, that's all for today's session. Thank you.